Assalamualaikum, we are from Group 5. Today we will be presenting our group project about simulation study of queuing system in bank. Next, what is queuing theory? Queuing is the mathematical study of the congestion and delays of waiting in line. The objective of this study are to minimize waiting and service time. We also want to optimize the number of servers which we want to improve the services provided. Next, for the scope of study, we will look into one type of system which is single server. We will use data from the withdrawal check in Ogun State Bank from 8 a.m. until 15 p.m. For this project, we only focus on first come, first serve, which is FIFO. The problem of this study are the number of customer exceeds the number of server and also the longer waiting time and service time. Next, for data collection, we want to collect the arrival time, service time, and waiting time. All the time is in minutes. The method we use in this project to collect the data is by document and record from someone thesis. Now, I will pass to Fidaus to continue the presentation.
Okay, so now part for data analysis and interpretation. From the raw data, we get the arrival time, service time, and customer spend in the bank. From the data, we analyze the arrival time and service time to show the main objective for this project. We use the easy fit to analysis. For the part arrival time, we can see the graph given for arrival time sample size fit to uniform distribution. Next, we test the effectiveness of the sample size with goodness of fit test by using method Kolmogorov-Smirnov test. Then the result show the null hypothesis is accepted and the model followed uniform distribution. So the next part for the service time. The graph shows the service time sample size fit to beta distribution, and we test the effectiveness of the sample size for the service time with goodness of fit test by using method Kolmogorov-Smirnov test. Then the results show the null hypothesis is accepted when the level of the critical value greater than 95%. Then this model follow the beta distribution. Then the last part for the data analysis and interpretation, from the using EasyFit show the arrival rate is 51.024 and service rate is 0.09651. And the next slide we pass for the Paradamia.
Now, I will proceed on our model translation. The following is the model system for bank in urban area of Ogun State, Nigeria, using the information data provided in data analysis above. We can simulate the data analysis with Simulate software and analyze the simulation result. Based on our case, we first consider single server queue where the number of servers is equal to 1. Therefore, we only have one work center and one queue in the system as shown in the figure 1. So here, as you can see, we have created our model in Simulate software. We only has one work entry point, then followed with one queue, work center, and work end. For work entry point, it follows uniform distribution that mentioned in data analysis, with lower bound is -4 and upper bound is 107. Meanwhile, for work center, it follows beta distribution with alpha 1 is 1.8679, alpha 2 1.9342, with minimum 4.745 and maximum 16.164. Now I will run our model. So this is our result, and I will further discuss this in our next slide. Of a system. significantly different from the true result. The most commonly used measure of performance in a queuing situation are LS, known as expected number of customer in system, LQ as expected number of customer in queue, WS as expected waiting time in system, and WQ as expected waiting time in queue. Using simulate software, we can attain the value of steady-state measure of performance. Figure 2 show the total work completed in a system, which is 203. Meanwhile, figure 3 show the average number of customer in queue, where it is 0.02 and the maximum is 3.0. Next, figure 4 shows the expected waiting time in system, where the average time is 12.40. The maximum time in system will be 41.01, while the minimum time will be 6.04. Lastly, figure 5 shows the expected waiting time in queue, where the average waiting time is only 1.15 and the longest will be 27.39. Now, I will explain on verification and validation. For verification process, the model was implemented correctly in the simulate software. Using the distribution that we obtained from the data analysis, it is shown that all the input parameters and logical structure of the model is represented correctly. While conducting the model using the process debugging, there are certain errors that was detected. One of it is when we did not change the clock properties, as the bank are open for 7 days per week and the running time is 24 hours. Thus, the model shows incorrect operation and not accepted for the best model. In conclusion, we can say that the simulate model on the figure above meets the specification. For validation process, the simulate model is created with high rationality and understandable to the policymakers. The system is known as single server model, and based on data analysis, the alternative hypothesis is true at the 95% confidence level. Thus, we can say that the specification captures the customer's need. Now, I will pass the presentation to Tuan Aminuddin.
Thank you, Fadamia. Okay, for the experimental design, we have two concerns in our variable. The first one is resources, or we call it is counter in real life situation. And for the second variable is queue. For the first experiment, we're gonna change the resources, but we static the queue. And experiment 2, we're gonna change in the number of queue and we static the resources. And for the experiment 3 and so on, we're gonna change both variable. Okay, next. So from the experiment, we have conclude that the so in the graph, in the picture, sheet show the best queuing model in the system. As we can see, the number of resources is 4 and the queue is 1. For the figure 7, show the average spending time of the optimal model. So the average, the optimal average is 11.25. Okay, next. So the conclusion is the best number of queue and resources are at 1 and 4 respectively. For the second conclusion is keep queue organized. Fully organized queue can contribute to the frustration of the customer once he or she in the waiting line, and in some situation can put people off entering the queue altogether. During busy time, line can often get longer than queuing area and disturb people who are not willing to wait during the line, creating even more frustration. And the last conclusion is increase customer loyalty and retention rate. Terrible queuing situation can indeed cause customers to choose not to go back to the store. In a community where we have so many other choices, if our demands are not met, including visiting a competitor shop or even going online, it is important to ensure that we maintain loyal customers. So from our journey in this particular model, it is important to keep queue organized and increase customer loyalty and retention rate of the clinic. I think that's all from us. Thank you.